So this lesson's on applying the product of powers property. Okay. Now, with this property, it's a very straightforward property, but where it comes from is very important to understand. So right away, when we go to simplify these, when we simplify, we're going to basically break it down to a single numerical value or write it as it's going to be a big number, a product of two numbers or something raised to an exponent. So here I can write this as 3 times 3 times, and then in this case, right, I'm going to do 3 times 3 times 3 times 3 times 3 times 3 times 3. Now, when I look at it, if I were to take all of these 3's linked by multiplication, how many do I have here? I have 10. So I would rewrite this as 3 to the 10th power. Okay, now over here, I have 5 times. How many 5's do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all linked by multiplication. So if I had to look at this and rewrite it using exponents, I would write it as 1 base 5 because that's the number that's being repeated multiplication, and raise it to how many 5's am I multiplying? 10. Here, we would have negative 7 times negative 7, then negative 7 times negative 7 times negative 7. So my base would be negative 7, and how many negative 7's am I multiplying together? 5. So it would be negative 7 all to the 5th power. So when I go and talk about, right, this here, right, this property, x to the second times x to the 6 times x, right, we get x times 1, 2, 3, 4, 5, 6, and then we have one more. How many total x's am I multiplying together here? Ends up being 9. So I would simplify this as x to the 9th power. Well, the first thing we're going to talk about here is the product of powers property. And what this property says is if I have x to the m times x to the n, meaning my bases are the same. If this base is the same as this base, right, I can write it as one single base, but then what I do with the exponents is I would add them together. Okay, so what this exercise did, if you look, instead of writing these all out, I could have easily just done 3, oh, sorry, this was 9. I'm sorry about that. I could have written as 1 base 3, add the 2 and 7 to get 3 to the 9th power. Here, if you don't see an exponent, the exponent's 1. So I could have written it as 5 to the 1 plus 9 gives you 5 to the 10th power. My base here is negative 7. What do I do with the 2 and 3? Add them together, get negative 7 to the 5th. And here, I could write it as 1 base x. I'm going to take 2, add 6, but then I also have to add this 1, and that would give me x to the 9th. So an easier way to do these problems would have been to just add the exponents. The next one, if I were to give you, right, the problem x to the 3rd all to the 2nd. What this exponent tells me is if my base is x to the 3rd, I'm going to take x to the 3rd and multiply by x to the 3rd. Now, if I expand x to the 3rd out, I get x times x times x times x times x times x. Well, how many x's do I end up with here? 6, so that would simplify to x to the 6th. All right, let's do another one. Let's go y to the 2nd, right? Or, yeah, y to the 2nd to the 4th power. So that would be y squared times y squared times y squared times y squared. And now if I simplify these out, y times y, y times y, y times y, y times y. Now, how many y's do I have here? 8. So this would simplify to y to the 8th power. Well, when you look at this, is there an easier way to get from, right, this to here? Is there an easier way to get from here to here? Well, what could I do with the exponents here to get 6? what can I do with the exponents here to get 8, right? And that is multiply them together. So the next property is the power of a power property. And we're going to say if I have x to the m, and I take it and raise it to some n power, when I go to simplify a power to a power, I'm going to just multiply the exponents. So right here, I look for my base, right? The property I'm using here, x to the m to the n, is x to the m times n. So right here, what's my base? 2. What can I do with 5 and 3? I'm going to multiply them together to get 2 to the 15th power. Done. Here, what is my base? My base is negative 6, right? What am I going to do with the exponents? Multiply them, and that becomes negative 6 to the 10th power. X to the second to the fourth is x to the 2 times 4, which would give me x to the 8th. Power to a power, we multiply. Now in this last example, what you have to understand is this here is my base. I have to write that and keep it in parentheses as y plus 2. Now I'm going to go ahead and multiply the exponents, and I end up with an answer of y plus 2 all to the 12th power. Okay, so remember, a power to a power, we are basically multiplying the exponents. Now, a product of a power property. Okay, so if I give you an algebra example where I give you 3 times 2, right, to the second, a lot of times what people would do is to do parentheses first. That would give you 6. And now I would take 6 and raise it to the second power, and I would get 6 times 6, which is 36, right? However, another way I could do this to get the same answer is since I'm linked by multiplication inside here, right? This is multiplication. What I'm going to do is take each of these factors, the numbers being multiplied, and raise it to this exponent. So I'm going to do 3 to the second times 2 to the second. What is 3 to the second going to give me? 9. And what is 2 to the second going to give me? 4. Now 9 times 4 is what? 36. Now the thing is, a lot of times these numbers inside cannot be combined to one single term. So what do we do if we can't do that? What we say is if I have a times b all to some m power, everything being multiplied inside gets raised to that m power. So it'd be a to the m, b to the m. Okay, so let's put it into play here. So right now, if I had this could be a pretty big number, right? So an easier way to write it is to take 24, raise it to the 8th power, take 13, raise it to the 8th power. Now over here, notice I have 2 variables and a coefficient here. So what I'm going to do is raise everything to the second power. When I do that, 9 to the second power, you have to understand, is going to give you 81, because 9 times 9 is 81. Then it's just going to be x squared, y squared. Done. Now the next example, this is where it starts to get a little complicated. What you have to understand here is I'm going to raise everything inside here to the 4th power. Now the first term is just going to be negative 4 to the 4th power. What is that going to give me? Well, once I look at that, negative 4 times negative 4 times negative 4 times negative 4, it's going to give you 16 times 16. So this will simplify to 256. But the part you have to really focus on here is now, when I do the x, when I raise x to the second to the 4th, I have to multiply those exponents. To get x to the 2 times 4 is 8. When I simplify the y's, y to the 3rd to the 4th, now what am I going to do with those exponents? Multiply them to get y to the 12th. So remember, we're raising everything here to the fourth power. And when I do that, everything inside has to get raised to the fourth power, and I have to use all the properties I've learned just a minute ago to do that. So the next one, is this negative inside or outside the parentheses? All right, it's outside. So that is going to be like -1 times something. Now what I'm basically doing is raising everything inside here to the fourth power. 3 to the fourth, x to the third gets raised to the fourth, y squared gets raised to the fourth, z to the fourth gets raised to the fourth. But now remember, this is going to be -1 times 3 times 3 times 3 times 3, which gives you -1 times 9 times 9, which is going to give you -81. Now, when I raise a power to a power, what am I going to do with these exponents? I'm going to multiply. 3 times 4 gives me x to the 12th. 2 times 4 gives me y to the 8th. 4 times 4 gives me z to the 16th. Okay? So you're using a combination of two properties here. All right, let's look at a couple of other examples. So right here, when I look at this first example, I have to recognize, is there any exponents outside the parentheses I have to get rid of? No. So now all I'm going to do is multiply coefficients together, and then I'm going to multiply same bases together. So I can multiply 6 and 2 together. What is 6 times 2 going to give me? 12. Now, when I do n to the third times n to the seventh, when I multiply these, what am I now going to do with the exponents? This is where I add them. When I multiply same bases, going back to the very first property, what do I do with the exponents? I add them, and my final answer is 12n to the 10th. Now the next one, first thing I'm going to do is get rid of these exponents on the outside. So do I have to raise this quantity to anything? No. So that's -2 g to the third h. But now when I raise this to a power, that's going to give me -3 times -3 is going to give me 9 g to the second. But now j to the fourth to the second. When I do this, what do I do with the exponents? This is where I multiply. So it's going to be j to the 8th. Now the last one here, think of this as -1. So -1 to the fourth is -1 times -1 times -1. This is going to give me +1 times this is going to give me +1. 1 times 1 is 1, so I get 1. That's going to give me g to the fourth. H, remember, now I'm multiplying these. 3 times 4 is h to the 12th, and j to the 4th. So now, when I go to multiply these out, I'm going to multiply coefficients together, and then like terms or like variables together. So -2 times 9 is -18. -18 times 1 gives me -18. Now, g to the third times g to the second, so I'm going to add 2 times g to the fourth, now I'm going to add 4. When I multiply these same factors or same bases, I'm going to add all the exponents. When I do the h's, I have h, that exponent's 1, so it's to the 1. I don't have an h here, but I have h to the 12th here, so plus 12. And last, my j's. No j here, but j to the 8th times j to the 4th. I'm going to add those exponents. So I get -18 g to the 2 plus 4. We give you 9. H to the 13th, and j to the 12th. And whenever you have multiple variables, I always like to go in alphabetical order. Okay? Couple more examples here. This, we're going to go x to the third to the second, so 2 to the second is 4. X to the sixth times x to the 4